Welcome to Brain Vision.
So for part A, we know that the linear speed of the train must be the same as it passes over both sprockets. So the linear speed is related to the angular speed. The velocity would be equaling to omega times r. And so we can say omega sub r times r sub r equaling omega sub f times r sub f. So the angular velocity of the rear multiplied by the radius of the rear equaling the angular velocity of the front multiplied by the radius of the front. We can say that if the teeth on the sprockets is separated by a distance d, then the number of teeth and d, the number of teeth times the spacing, would be equaling the circumference of the sprocket, so 2 pi r. And so r equaling the number of teeth on the sprocket multiplied by the spacing between the teeth divided by 2 pi. And so we can then say that omega r times nrd divided by 2 pi would be equaling omega sub f times n sub f d divided by 2 pi. And essentially we find that the angular velocity of the rear sprocket divided by the angular velocity of the front sprocket would be equaling the number of teeth on the front sprocket divided by the number of teeth on the rear sprocket. And this would be our answer to part A. Again, n being number of teeth on sprocket. For part B, we can say that the omega sub r divided by omega sub f, this is going to be equaling 52 over 13. And so the ratio would be 4.0 between the angular velocity of the rear sprocket and the angular velocity of the front sprocket. For part C, omega sub r divided by omega sub f, this is equaling 42 divided by 28, and this is equaling 1.5. So 4.0 would be your answer for B, 1.5 your answer for part C. That is the end of the solution. Thank you for watching.